x of t is equal to y cos t plus z sin t for all t. Y and z are independent binary random variables, each of which assumes the values -1 and 2 with the probabilities 2 by 3 and 1 by 3 respectively. Prove that x of t is Whitson stationary. Here, given x of t is equal to y cos t plus z sin t. One more condition is given as y and z are independent binary random variables, each of which assumes the values -1 and -2 with the probabilities 2 by 3 and 1 by 3 respectively. That means y and z are discrete random variables. Y and z are discrete random variables. Discrete random variables, and its probability is also given. That means y p of y, if y is equal to -1, its probability is 2 by 3, and if y is equal to 2, its corresponding probability is 1 by 3. Same as in the case of z. P of z, if z is equal to -1, corresponding probability 2 by 3, and z is equal to 1 by 3, z is equal to 2, corresponding probability is 1 by 3. Then now we can find the expectation of y. Expectation of y is equal to summation over y into p of y. Similarly, expectation of z is equal to summation over z into p of z. Expectation of y is equal to -1 into 2 by 3, 2 into 1 by 3 is equal to -2 by 3 plus 2 by 3 equal to 0. Similarly, expectation of z is equal to -1 into 2 by 3 plus 2 into 1 by 3 minus 2 by 3 plus 2 by 3 is equal to 0. Now we will have to find E of y square. E of y square is equal to summation over y square into p of y. That's equal to -1 square into 2 by 3 plus 2 square into 1 by 3 is equal to 2 by 3 plus 4 by 3 is equal to 6 by 3. Its value is 2. Now we'll have to find E of z square. E of z square is equal to summation over z square into p of z is equal to -1 square into 2 by 3 plus 2 square into 1 by 3 is equal to 1 into 2 by 3 plus 4 into 1 by 3 is equal to 2 by 3 plus 4 by 3 is equal to 6 by 3. Answer is 2. Now we'll have to find E of y z. E of y z can be written as E of y into E of z. Reason is y and z are independent random variables. Reason is y and z are independent random variables. Now the value of E of y is equal to 0 and E of z is equal to 0. 0 into 0, answer is 0. Now we will have to find now we will have to find x of t. Expectation of x of t. Expectation of x of t is equal to expectation of y cos t plus z sin t, that is equal to E of y cos t plus E of z sin t, 0 into cos t plus 0 into sin t. Answer is 0, which is equal to a constant. Now we will have to find Rx of tau, which is equal to expectation of x of t into x of t plus tau. We have given the function x of t is equal to y cos t plus z sin t, and x of t plus tau is equal to y cos t plus tau plus z sin t plus tau. Expectation of x of t into x of t plus tau is equal to expectation of y cos t plus z sin t into y cos t plus tau plus z sin t plus tau, that is equal to expectation of y square cos t plus tau plus yz cos t sin t plus tau plus yz sin t cos t plus tau plus z square sin t plus tau. Now expectation of y square cos t plus tau plus expectation of yz cos t sin t plus tau plus expectation of yz sin t cos t plus tau plus expectation of z square sin t plus 2. You have already found the value of e of y square, e of yz, and e of z square. Value of e of y square is equal to 2 and cos t plus 2 plus value of e of yz is equal to 0 into cos t sin t plus 2 plus 0 into sin t cos t plus 2 plus 2 into sin t into sin t plus 2, which is equal to 2 cos t plus 2 plus 2 sin t sin t plus 2. This is of the form, which is again 2 can be taken outside. We'll have to write cos t plus 2 plus sin t plus 2. This is of the form cos a cos b plus sin a sin b. Cos a cos b plus sin a sin b is equal to cos a minus b. So the above function can be written as 2 into cos a is equal to t and b is equal to t plus 2. T minus t plus 2 is equal to 2 into cos minus 2. Cos is an even function. Cos minus theta is equal to cos theta. Therefore, we can write cos minus 2 as cos 2, which is a function of 2. Therefore, x of t is a WSS process. For a random process x of t, y sin omega t, where y is an uniform random variable in the interval -1 to 1, check whether the process is WSS process. Given random process is x of t, which is equal to y sin omega t, and one more condition is given. Y is a uniform random variable in the interval -1 to 1. Therefore, f of y is equal to 1 by 1 minus 1 from the interval minus less than y less than 1 and 0 elsewhere, which is equal to 1 by 2 minus 1 less than y less than 1 and 0 elsewhere. Now we will have to find the expectation of x of t. Expectation of x of t is equal to expectation of y sin omega t. Here y is a random variable, so expectation can be applied only to y, that is expectation of y, and the sin omega t is a constant. It will come out to the now expectation of y is equal to integral over y into f of y dy, that's equal to integral over -1 to 1 y into 1 by 2 dy is equal to 1 by 2 integral minus 1 to 1 y dy is equal to y square by 2 into 1 by 2 from the limit minus 1 to 1 is equal to 1 by 2 1 by 2 minus 1 by 2 is equal to 0. Now it can be applied to this function. We will get expectation of x of t is equal to 0 into sine omega t, which is also 0. It's equal to a constant. Now we will have to find Rxx of t1 t2. Rxx of t1 t2, which is equal to expectation of x t1 into x t2. You can use this formula or you can use Rxx of t plus 2. Any formula we can use. X of t into x of t plus 2. I am using the second one, Rxx of t plus 2. Expectation of x of t is equal to y sin omega t and x of t plus 2 is equal to y sin omega t plus 2. Expectation of x of t into x of t plus 2 is equal to expectation of y sin omega t into y sin omega t plus 2, that is equal to expectation of y square sin omega t sin omega t plus 2. Now we will have to find expectation of y square, which is equal to e of y square into sin omega t sin omega t plus 2. Then now we have to find expectation of y square. E of y square is equal to integral over y square into f of y dy, which is equal to integral over minus 1 to 1 y square into 1 by 2 dy, 1 by 2 into integral minus 1 to 1 y square dy. Here one formula is there. Integral minus a to a f of x dx can be written as 2 into integral 0 to a f of x dx if f of x is an even function. Here y square by 2, y square is an even function. We can write 1 by 2 integral minus 1 to 1 y square dy can be written as 1 by 2 into integral 0 to y square dy. Now 1 by 2 integral y square can be written as y cube by 3 from the limit 0 to 1 is equal to 1 by 3 into 1 by 2 1 by 6 into y cube from the limit 0 to 1 is equal to 1 by 6. Now expectation of t plus 2 is equal to e of y square into sin omega t sin omega t plus 2. E of y square is equal to 1 by 6 sin omega t sin omega t plus 2. This is of the form, this function is of the form sin A sin B. Sin A sin B can be written as 1 by 2 cos A minus B minus cos A plus B. Here A is equal to omega t and B is equal to omega t plus 2. Substituting this equation, we will get expectation of x of t into x of t plus 2 is equal to 1 by 6 into cos omega a minus b omega t minus omega t plus 2 minus cos omega t plus omega t plus 2 is equal to 1 by 6 cos minus omega 2 minus cos omega into 2t plus 2 which is equal to 1 by 6 cos omega 2 minus cos omega 2t plus 2. It is not a function of tau itself. So x of t is not an not a WSS process. X of t is not a WSS process.